All right. So, symmetry. Symmetry is the topic of discussion for this particular video, and so we want to be able to talk about the idea of symmetry within a graph. And so there are three types of symmetry. Our first type of symmetry is going to be symmetry we call over the x-axis. The key thing to think about if we think about symmetry of the x-axis is that I'm going to put numbers on this. So if you want to draw some sketches, let's say that this ordered pair right here is over 4 and up 3. Then if you're symmetrical over the x-axis, that means that the correlating point, that related point, that reflected point, that point of symmetry would be at positive 4, negative 3, meaning that the x values don't change, but the y's do. So when you have a reflection over the x-axis, the y's are what change value. The outcome changes its value. The next type of symmetry is symmetry about the y-axis. And in the y-axis, it's opposite of the x. So if we put a number on this guy, we'll call it once again 4, 3. So we come over here and we find its symmetrical point on the other side. Whoops. That would be negative 4, 3. So it's the x coordinate. When you're symmetrical over the y-axis, it's the x value that changes its sign. Then our third type of symmetry is going to be symmetry over the origin. And when you have symmetry over the origin, we'll use the same numbers just for the sake of conversation. So 4, 3. That means when we're down here, that this would be, the symmetrical point would be negative 4, negative 3. And so at this point we can see, so when you have symmetry over the origin, that means both your x and your y signs are going to switch. So taking that right along, go ahead and draw yourself a quick little sketch of this graph right here. Plot your point for me, please. That'd be negative 3, positive 4. And based upon that, go ahead and plot your symmetry over the x-axis, plot your symmetry over the y-axis, and plot your symmetry over the origin. And then come back and hit play on the video and check your answers. So symmetry over the x-axis, that means that I'm 4 units above, 1, 2, 3, 4. So I'd be 4 units below, 1, 2, 3, 4. So this is my parent function. This is my starting point right there. So that would be symmetry over the x-axis, and you can see that point would be negative 3, negative 4. Alright, we go to symmetry over the y-axis. So from the y-axis, I was 1, 2, 3 units away. So from the y-axis, I'll be 1, 2, 3 units away. And so that ordered pair would be 3, 4, because it's the x value that changes when you're on the y. Last, and we can do this however we want, we can do it off of a reflection off of the x coordinate here in quadrant 1. We can do it off of the quadrant 3. Or we can just do the idea that we can switch our signs. And so if we switch our signs, that just means that we were at negative 3, positive 4. We'll be down here. That will be positive 3, negative 4. So we come over positive 3, go down negative 4, and that would be us right there. So that's just practicing the idea of the different types of symmetry. There's more to that, but that's just kind of a touch base and make sure we're on the right track with the concept of symmetry. Let me hit pause and see where we are. So I've got one last little thought on this video. Actually, this is the last video, and that is, so what happens if someone gives you an equation or a problem like something like this and says, okay, well, your parent function for this guy is y equals, sorry, I'm getting a little bit of lag here, y equals the square root of x. But I want you to come up with an equation that has the following transformations. I want it to be shifted up 5 times. So I'm going to break it down by parts. So if I wanted to shift it up 5 times, that means I'm going to do my square root of x, and then on the end I'm going to add 5. Not under the radical, on the outside, because remember the vertical transformations come on the outside. Alright, I'm going to make the next one. So the next one is number 2, so that's number 1. Number 2, if I want to reflect something about the x-axis, that means I'm going to change the actual y value. And so when you do that, it's really interesting. It's that you actually just make the whole thing negative. So it's like you do the original function, but then you make it negative. So you can see here it says take the function and make it negative, and that will give you the same. Oops, sorry. Excuse me. I just put it in the wrong spot. Let me hit pause. Let me double check my thought process here. Alright, so I made a mistake. Let's go back and take a look at this. So the best way for us to understand these transformations, once again, is with your technology, right? So what I did is that I plugged in the square root of x as my parent function, and then I did the negative. Okay, so this would be the negative on the outside. So let me go turn this one off real quick, so there's not too much competing for our attention. Getting a little bit of lag, sorry about that. Okay, so now I've got that taken care of. I've got the square root, so I'm going to graph this. So what we're looking at is, on our calculator right now, is we have two different ways we can do this. We have the negative square root of x, and we have the square root of negative x. And what I'm trying to show you is which one's which. Alright, so I hit graph, take a look. So there's the parent function. Alright, remember, right now, we're looking at this guy. Excuse me. Man, I keep making mistakes. We're looking at this guy. So that we're comparing the parent function to the negative square root of x. That looks like that's a reflection over the x-axis. So this one would be the negative square root of x. So I didn't make a mistake. I was okay, wasn't I? Alright, let me make sure one more time. Alright, so bam, negative square root of x, looking good, the negative's on the outside. Alright, so that means for number 3, y is equal to the square root of negative x. So we come back to our y equals. If you notice, I'm arrowing on top of the equal sign. I can press enter and turn it off, and then I can press enter and turn it on. So you can see I have the two turned on that I want to compare. I hit graph. There's my parent function, and then there is my square root of negative x, which is clearly a reflection over the y-axis. Alright, so putting it all together, we take it all together and put all those transformations into one, we would get y is equal to negative square root of negative x plus 5. And that's the particular answer that they're looking for in this one. So I just wanted to touch base and kind of finalize there how this idea of reflection works and where it goes when you plug it inside of the equation. But the key thing is, y'all, is please make sure you're using your technology to compare the parent function with the actual function that you're looking at so you can actually see the transformation. Alright, that wraps this up. This is 3.1.